Hey guys, Brian Tebow here. Today I'm going to talk to you about artificial intelligence facial recognition, give you some background, and then talk about Facebook's newest algorithm called Deepface. So a little background. What are some uses of facial recognition? We've all seen the television show where the FBI agent hits go and then it parses through everybody in the known world and finds a match for the criminal. Uh, Although that's a little fictionalized, that is one use for law enforcement. Biometrics, it's apparently AI recognition is almost to the security level of fingerprint, and from my understanding, that's not very secure. To do this kind of biometric facial recognition, you actually need it's a geometric facial recognition. You need a 3D camera um, or 3D, specialized sensors and hardware that project light onto the surface of a face and then get the geometric shape of the face. And that's also, it has to be in a constrained environment, with controlled background and everything else. That is a high precision use of or type of facial recognition. I think a more common application is probably something we're all familiar with, is Facebook photo tagging, or on a Mac iPhoto, something like that can actually identify your face now in a group of people. So how does that work? Typically, there's a couple algorithms that people use. Ein faces, Fisher faces, Gaussian face is a new one. These are all subject to typical photo problems: lighting, occlusions, background clutter, facial expressions, things like that. And they have gotten better even in the last 5 years with the advance in hardware and cloud computing and GPUs. So it is getting better. So the gold standard, the training set for any type of machine learning algorithm or even Deepface, which we're going to talk about, is this labeled faces in the wild. So that's here's the URL. You can go there, check it out, and here's a sample. So Deepface, developed by Facebook, it's 97.3% accurate on the labeled faces in the wild data set, which is close to a human level. Uses deep learning neural networks to make all this happen. So they have a unique approach. Instead of cataloging, using a catalog of tens of thousands of facial features and comparing, they use a very rapid 3D alignment, which is performed, and then the individual pixels using RGB are looked at. So what is 3D alignment? That is, we'll see an example of it here in a second, but that's taking a photo that may be a little bit of askew, or maybe the person's looking away a little bit, mapping it into 3D and then rotating it so it's facing forward. So basically, here's the Deepface approach where all the magic happens, apparently. So we have a photo of everybody's favorite actor, Sylvester Stallone. We crop it down. We model it in 2D using what are called fiducial points, which are reference points on the face. Uses 6 of them. And it divides it up into these triangles. So eventually we get to a 3D model down here with 67 reference points. And then you can see, so his face is a little askew, he's looking to the right. They've actually frontally rotated it on a plane into this photo. Okay, and they have a 3D model. So again, this is what makes the magic happen for Deepface. So they feed this into an 8-layer neural network, mixed of convolutional layers, locally connected layers, And then eventually they get an output, which is to capture the correlations between features, like the distance between the mouth and the nose. So they normalize that data, send it, and then are able to compare against a known data set and get that accuracy level. I'll post these slides here in the Dropbox and on my YouTube site. But these are the sources I've used. Here's a couple open source tools. OpenCV, Microsoft Project Oxford, and GitHub project using Deep Neural Networks OpenFace. Thank you.